Hi, everyone, and welcome to our webinar on BuildIT Projector. My name is Maxime Isabelle, Senior Application Engineer at BuildIT, and I'll be your presenter for this webinar. Should take about 20 to 25 minutes. Before we move on to the main course, I'd like to cover a couple housekeeping points. First, if you have any questions during the webinar, use the Q&A button on the right, and I'll try to answer them as we go. If not, I'll answer them at the end or in a follow-up email. Also, it's recorded and it may be made publicly available in the future. So assembly can be complex, whether you're dealing with bracket placement, rib and stringer placement, click bonds and standoffs, paint templating and masking, factory floor layout for production lines, fencing and robotic station layouts, ship, yachts, boat building, and marine construction, railways. The list goes on, and you yourself might be thinking uh, of an assembly process in the workplace that has a certain complexity. What makes an assembly so complex? It boils down to essentially two things: the sheer quantity of information and also the nature of the information. There are annotations, there's information on which method, which tool to use, how to use it, where. There's a specific sequence that needs to be followed. There's the position of the object and how it's rotated. There are many ways to deal with um, properly assembling your assembly. There's templates, jigs, measurement devices, and at BuildIT we're very familiar with this because a lot of our clients use BuildIT to assemble jigs using trackers, especially. There's also 6 degree of freedom tracking devices. It tracks all 3 translations and rotations. And there's even the tape measuring method. And with every method, we're trying to improve the same things. Increasing throughput, reducing training time, and reducing non-conformances. And there's 3 components of the assembly process that I want to focus on in this presentation as we look at more modern ways of managing these components. And that's following a proper sequence, having the special instructions in a timely manner, and also having an accurate and precise positioning. Augmented reality is a technology that's emerging both in manufacturing and also for consumers. There are technologies there that we're already familiar with. There's the Google Glass, which, as a matter of fact, it was originally aimed at businesses and for manufacturing. The management got excited by this technology and tried to market it to us consumers, and as we all know, that really flopped. But that's not the end of Google Glass. They're actually redirecting their efforts back into manufacturing. But that's not exactly what I would call real or full augmented reality. Something that's closer to that is the Microsoft HoloLens, which is the image that you see at the bottom. And that I find is an exciting technology that we're going to be able to use in our own living room. In this case, this technology is aware of the shape of its surroundings. Unlike the Google Glass, which is it's a tiny screen that you see on the side of your periphery, this one is aware of the shape of things and really maps 3D images onto that. And also, I thought an interesting example would be the middle one, which is a projector that detects the shape of the sandbox under it, and it'll color code it, making it blue when it's below quote unquote sea level, and it will also color code the peaks red. So you get this real-time topographical map. You can shift the sand around and you'll get a new color map. And so the difficulty or the complexity right here, again, is really the device needs to be aware of the shape and the position of the object that it's projecting on. If you take your conference room projector, for example, that only works on a flat surface. If you tilt or warp the surface, the projection changes, and that's not good. So that projector has no spatial awareness. Now, Faro, our parent company, is taking significant steps in that direction, releasing 2 products, the Tracer M, which I'm going to get more into in more detail later, and then there's the Visual Inspect, which runs on a tablet. It detects whether a component of your assembly is missing. Visual Inspect, as well as the other technologies that we saw earlier on the consumer side, they are focused or they use the device's camera. And while the device camera are getting better with more resolution, and the software also is getting more sophisticated, we still don't have a lot of precision in terms of positioning, and that's really important in manufacturing. So if you need high precision, there's really one product that can fulfill that need, and that's laser projectors. And that's been used on shop floors for a long time already. They have the ability to guide an assembly process, and also it accurately locates and orients components, and it makes makes manufacturing a lot more efficient. So at this point, I wanted to ask you guys a question. Are you currently using a laser projector? So we have on the right, you should see a button that says a new poll is live, and there's a blue dot on it. If you open that sidebar, you're going to have a few options. I'm going to bring that up on my side. And so the possible answers are yeah, all the time. We have one, but we aren't using it much yet. We just got one. We're looking to get one. We're not sure if we want to get one yet. Or wait, what's a laser projector? So cast your votes. If your vote is the last one, you might be in the wrong webinar, but we are going to cover a little bit of what's a laser projector in the next 5 minutes. So you should stick around, actually. So I'm gonna leave that there. You guys can take your time, I guess, to vote. I'm gonna get to the next slide, and I'm gonna come right back to it. So the Faro Tracer M is a 3D laser projector that provides a virtual template for operators so that they can quickly and accurately position components with confidence. They've been in the game from decades ago. They're rugged and reliable, and Faro recently acquired the technology, so you can benefit from Faro's extensive and international support system. It eliminates tooling, templates, and tape measures. It's the sharpest laser and has the highest positional accuracy on the market. The lines that it projects can be as thin as 0.5 millimeter. I'm just gonna have a look at the poll. Look at the results. Okay, so a lot of you use it all the time. Some use it not so much, and some are not sure if you need one yet. And there's some people who are not sure what's a laser projector. So I'll get right into that. So virtual templating, well, 3D laser projectors project a glowing image of the part, component, or the location directly on your work surface. And this, by projecting a glowing image, you get an accurate guiding template, and also it can be seen by anybody with a naked eye. So unlike other augmented reality technologies, this one is excellent for collaborative tasks. There's no need for physical templates or hard tooling, so it's cheaper. On top of that, it's faster, and it's also more intuitive to use. How does it do those projections? Well, there's a laser that shoots the beam, which first bounces off of 2 mirrors before exiting the machine. And these 2 mirrors are mounted on these galvanometers. And these galvanometers are able to steer the mirrors at very high speeds, high frequencies, so that the line moves so fast that it will go through the full pattern maybe 60 times a second. So at that speed, it's indistinguishable from a line. And just to give you kind of a comparison, most movies on films are projected at 24 frames per second, so 24 hertz. So that's less than half of the typical speed of that kind of projection. The range of this technology is 15 by 15 meters, or 50 by 50 feet. If you have something that's bigger than that, what you can do is you can connect multiple projectors simultaneously. And also the beam itself stays focused, whether you're projecting it from 6 feet to 50 feet, or 1.8 meters to 15.2 meters. Now, before moving on to the software side of things, I wanted to go over more examples to help you see how it might apply to you. So at the top, We see a weld block placement where the user simply needs to line up the edges. And then there's hole drilling, which you can see there's the crosshairs that tell you exactly where to drill the holes. You can have text projections with special instructions. So for example, for the hole drilling, we could project which drill bit to use. And finally, you can use it for verification to make sure that the part is properly positioned. In all these cases, you get an increase in throughput. And especially since it's so much simpler than using a tape measure, for example. And so therefore the training is reduced as it tells you the right info at the right time. The errors are also reduced as it's easy to see when a projection doesn't line up. So now the BuildIT Projector software. That was released only a couple months ago,